Hey guys, we're going to talk about how to graph polynomials, but before we do that, the question that you're going to ask me immediately is, why can't I just plug this into my calculator? Why can't I just plug this into Desmos and it give me the graph? You're right, we totally can. But I've had students say 3 plus 5 is equal to 15. Well, that's not true. 3 times 5 is equal to 15. And what they did was they put into their calculator wrong. If we know this is not true, we know we made a mistake in our calculator. The same is true for what we're learning today. We are going to use our calculator for the future, but today's lesson is to help us, when we put it into our calculator, understand, did we do it correctly? So the first thing is our basic equations. Our basic equations are going to be x squared, x to the third, x to the fourth for today, okay? Our exponent, okay, if it is an even exponent, our arrows are going to go in the same direction, okay? If they are odd, our arrows are going to go in opposite directions. So x to the fifth, even though that's not one of our basic ones, we know that some kind of squiggle happens and then the arrows go in opposite directions. The same is true with x to the first power. It's just a linear line, but the arrows go in opposite directions. What we also know is that there's going to be some term a in front of each one. If a is positive, then we know from left to right, it's going to go from down to up. However, if it is negative, it's still going to go in opposite directions, but we're going to go from up to down in some direction like that. If our a term is positive, we know it's going to go up. And if it's negative, we know it's going to go down. Notice I don't care about anything after the first exponent. Whatever the biggest exponent is, the rest doesn't matter. We just care about this leading coefficient. Okay? So again, odds go in opposite directions. If the a is positive, it goes up. If the a is negative, it goes down. Squares or to the fourth power, doesn't matter. If it is positive, my arrows go up. If it's negative, my arrows go down. Okay? Next thing, I just kind of wanted to draw what each one looks like. X to the first power is just a linear line. X to the second power is a parabola. X to the third power is these squiggly lines. X to the fourth is a W or an M, depending on positive and negatives. An absolute value is a V shape. The reason that these are our basic polynomials is because of this square. Absolute values do not count as polynomials because there's a hard break. It's not a curvy break. Okay? The exponent tells you how many times that it could cross the x-axis. It's not a guarantee, it's how many it could. So to the fourth is this W looking thing, right? How it works is if there are 4, it could cross 1, 2, 3, 4 times. And that's not always true. We could have one where it goes 1, 2, but the max times it can cross is 4 times. So if we add x to the third power, it could cross 1, 2, 3 times. 1, 2, 3 times. Or it could cross only 1 time and it'll still be true. This is just the max. Okay. How to find the zeros? If they give us x plus whatever, we are just going to say when y is 0, what's x? So for this one, we would say 0 is equal to x plus 1, and we would solve and say it crosses the x-axis at -1. Okay? If it is a squared, we would use our quadratic formula. And if they give us anything 3 or more, we are going to factor first, then use our quadratic. So an example might be that I have x to the third plus 2x squared plus x. Okay? So I factor out an x. I'm going to say this equals f of x. We're going to factor out an x. I have x squared plus 2x plus 1 is equal to f of x. And it is when it's equal to 0 is when we find r0. So now that I have two sets of numbers, x and everything inside this parentheses, I set each one equal to 0. So x is equal to 0, and x squared plus 2x plus 1 is equal to 0. Then I would quadratic this, and I'd figure out what this is. My quadratic should give me 2 answers, and this is my other one, giving me a total of 3 possible answers. Okay? The last thing is the intermediate theorem. All the intermediate theorem is saying is there is some kind of graph. Because this is a 3, I know it's going to make some kind of squiggle like this. Because a is positive, it's going up. Okay? And then they're saying between -2, -2, and 3. If I were to draw lines between those two, okay? I'm sorry. Between 2 and -3, does it have a point that crosses the x-axis? So to say that one more time a little bit better is we're going to figure out, does this graph between -2 and 3 cross the x-axis? So what we do is we change x to -2. So this turns into -8. This is going to turn into -4, because -2 times -2 is 4. 4 times negative is going to be negative. And then I get -10. Okay? Then I'm going to do the same thing again, but I'm going to plug in 3. So then I get 27 minus 9 plus 2. So I get 20. Okay? If you get a negative answer and a positive answer, okay, that means -10 and 20. That means that somewhere in between there, it had to have crossed 0. So yes, there is a 0. So all the intermediate theorem is saying is plug in these two numbers. If you get one negative, one positive, yes for a 0 in between them. If you get one of each, we would say no.